Today we're going to talk about section 5.5. These are the double angle identities that we're going to cover today. They are also on your green sheet, so you don't have to memorize them, you just have to know how to use them. The proofs we're going to do in another video at another time, so we're going to go straight to the one example on the back. So it says find sine of 2x, cosine of 2x, and tangent of 2x. So we'll start with sine of 2x. So sine of 2x just means that you are finding double the angle of x. It is doubling the angle first and then taking the sine of it. So we can't do sine of x and then double it. It would be out of order. So what we're going to have to do is use the formula for this. And the formula for sine of 2x is on the front. So first step is to write down the formula. So sine of 2x is 2 sine of x cosine of x. Now that we have written out in the formula, you can see sine of x, we can find that much easier. Sine of 2x we didn't know, but sine of x we can find that. And cosine of x we can find that because it's just a single x. It hasn't been doubled. So I'm going to have to look up the value of sine of x, and I'll have to look up cosine of x. Cosine of x I know, it's 5/13. Sine of x, they didn't give me, so I don't know that. And 2, I know is 2. So the only thing missing that I need to complete this problem is a sine of x. So what I'm going to do is go over here and look at all the information about x that I was given. First, I was given that cosine is 5/13, which means x is 5 and r is 13. Then I was also given that it's between 3 pi over 2 and 2 pi. So our angle x lives in here. Using Pythagorean's theorem, and where it is down the y-axis, I know that y is -12. Now when I need to go find sine of x, I can look at my drawing for the angle x and I can say y over 13, -12 over 13. I meant y over r, -12 over 13. So again, to recap, I wrote down my formula, then I found the values, and last I'm going to simplify. So 2 is really 2 over 1, so I have to do 2 times -12 times 5, so that would be -120, and then 1 times 13 times 13 is 169. So sine is done. Now I'll do cosine. Again, for cosine of 2x, I don't know cosine of 2x because I know cosine of x, but I can't just double it. I have to double the x first, and since I don't know what the x is, I can't do that. So the only option for cosine of 2x is to use the formula on the front. Now, I've been writing with markers, so you can't see it, but there are 3 different options for cosine of 2x, or cosine of 2 alpha here. You can use any of the 3. All 3 are also on your green sheet. I'm just going to use the first one. And so, first thing I do is write down the formula. Got that? Second thing is, I can look up cosine of x and sine of x. I'm using the same picture, so I don't have to redraw it. Cosine of x is 5/13. Sine of x is -12/13. And with order of operations with trig functions, you first look up the trig function, 5/13. After that, you square it. So I just did cosine of x, and I just did sine of x, and now I'll square both of those. So square, square, it would be 25 over 169. Square, square, it would be 144 over 169. And then I've got these 2 fractions. They do have a common denominator, which is nice. And I'll just have to subtract the tops, which is 119. Cosine is done. Tangent. You have 2 options for tangent, just like in the last section. The first option is to do the shortcut. And the shortcut is, when you're doing tangent, if you've already done sine and cosine for the problem, you can take those answers, which I have, and divide them. This is a quotient identity, and you're welcome to use that. The other option, which I don't like as much, is just to use the formula from the front. That works. I'm going to use a shortcut. So, what was this answer? Negative 120 over 169. And what was this answer? Negative 119 over 169. And now I just have to simplify that. So I'm going to same change reciprocal. And it looks like my 169s cancel and my negatives cancel. So I have 120 left on top and 119 left on the bottom. And that's it for tangent.